Assalamualaikum warahmatullahi wabarakatuh and good day. Now this video we continue with example 6.16. It's about ordered statistic. Okay, so from previous video there is a theory about the ordered statistic. You want to find the distribution function and the density function of the ordered statistic. So ordered statistic is very important because with ordered statistic you can see the fastest, or for example the fastest, the lowest, okay, the slowest, okay, so by using the order statistic, the relative magnitude. Okay, so now example 6.16, page 335. Electronic component of a certain type have a length of life y. Okay, so you have stray car, for example, you have iron, okay, you have vacuum. So this component have a length of life y. How long it can be used, okay, with probability density given by this piecewise function, okay, 1/100 exponent power negative y over 100. And actually you can see here, if you look this distribution, what can you see here? It seems like exponential. It seems, okay, but you can compare later. Okay, so the length of life is measured in hours. Okay, the unit of life is hours. Okay, suppose that two such components operate independently. So you have two electronic, okay, independently operate. For example, iron and vacuum, and in series in a certain system. Hence, the system fails when either component fails. That means the system will be fail if either of one is failure. So in my example just now, iron and vacuum is not really appropriate lah. Okay, but it seems like that. Okay, and then the question asks you, find the density function for x, length of life of the system. Okay, so if you look this solution, okay, because the system fails at the first component failure, so that means either y1 and y2, which one is failure at first, then it will be fail the system. Okay, so between y1 and y2, because you have two components, so which one will give you the apa will make you will make the system failure first. So that's why you will have x equal with minimum y1 y2, because it will be the first one, okay, where y1 y2 are independent random variables with the density given in previous slide. Okay, then because you have this distribution function, okay, because this is your density function, okay, and then you have this is density function for y, okay, for 1y, that means y1 y2. X is a density function, is the length of life. Okay, so if you look here, this is for y. From density function here, can you get your distribution function? Can, isn't it? You can integrate. All right, and then you want to find fx, okay, which is the density function of length of life. So you will have this g1y, okay, this is very related to with previous video, okay, the theory of the order statistic. So you will have n, so here you will have 1 minus fy power n minus 1 fy. All right, so you just substitute what is n, and you have 2 because you have two components. Then 1 minus fy, which one? This one. Okay, and then what is your fy? You have this one. All right, and then you substitute, you simplify, you will get this one. Then when you substitute, when you simplify, you will get 1/50 exponent power negative y over 50. So this is y greater than 0 and elsewhere. So the minimum of two exponential distributed random variable has n exponential distribution. So actually from here, you can see that this is exponential. Okay, you have 1 over theta, exponent negative y over theta. Theta is what here? 100. Okay, but here, when you have two component, okay, this one will follow the two exponential random variable has exponential distribution. So notice that the mean length of life for each component is 100 hours before, okay? Whereas the mean length of life for the system is 50, because you get 10 divided by 2. So that's why you have this one, 50. All right. So here, make sure you clear again, okay? Y is length of life of the component. X is what? Length of life of the system. Okay, so length of life of the system will be failure if either Y1 or Y2 break down. Okay, so that's why we need to look the order statistic between Y1 and Y2. Which one will give you the failure first? So that's why we use order statistic, and then you can see that we will find the minimum value between Y1 and Y2 first. Okay, and then you know that Y1 and Y2 is independent. Okay, so based on the density functioning, you can get this is for Y1, this is for Y2 as well. Then you can get the distribution function of Y. Okay, so you will have this one. Okay, so no need to explain here how, because you have learned how to get the distribution function of Y, capital Y. Okay, and then in order for you to get the density function of X, X is what? The length of the system. Okay, so you will use this method which is discussed from previous video. All right, you will have so actually if you look at the slide, you will get this one here. Okay, and one this one. All right, so by using that, you will have this equation. Okay, this function. Then you simplify, you will get this one. So this is X for system, but Y is for the electronic component. So here, that's why when you want to find expected mean length of life for system, you will get expected Y1, okay, Y ordered equal with 50, whereas 100 divided by 2. All right. Okay, so next we will discuss, in the next video, we'll discuss example 6.17. Okay, try understand this example and then do exercise. Thank you, class.